quick way to compute integral from 2 to infinity ln x over x squared dx is shown here. I'm going to use integration by part, which is a well-known identity. Integral u dv is equal to uv minus integral v du. Okay, and I'm going to rely on the fact that the derivative of negative 1 over x is equal to, with respect to x, is 1 over x squared. Okay, so knowing these, I'm going to rewrite this integral in this form. So equal to integral from 2 to infinity, and then ln x, and then instead of dx over x squared, I'm going to just write d minus 1 over x. Okay, this is what is supposed to be our u, and this is the dv that we expected to have. So now we have integral u dv. I can just reform it and restructure it in this form, and therefore it gives me uv, so it's going to be ln x times minus 1 over x, so it's negative ln x over x from, of course, 2 to infinity, so it would be 2 to infinity, and then we have minus v du. V is minus 1 over x, so minus minus becomes plus, so we have plus integral 2 to infinity 1 over x, and then du, which is d ln x. Okay, for this part, when x approaches infinity, we have to write limit x goes to infinity negative ln x over x, and then we have plus, so minus minus becomes plus, and then we can substitute x with 2, so ln 2 over 2, and for integral we have plus, so we have d ln x, which is 1 over x, so we get integral 2 to infinity 1 over x squared dx. Okay, for this one, when x approaches infinity, both numerator and denominator approaches to infinity, so we have to use L'Hopital rule. So that requires taking derivative of numerator and derivative of denominator. So we can rewrite limit when x goes to infinity, negative 1 over x in numerator, and then in denominator as simple as 1. Let's keep the ln 2 over 2. And for this one, it's a very simple integral. It becomes negative 1 over x from 2 to infinity. Okay, in this case, this limit is effectively the limit of negative 1 over x. When x approaches infinity, denominator goes to infinity, the whole thing goes to 0. So this just becomes 0. This is equal to 0. Let's keep the ln 2. So we have ln 2 over 2. And for this one, we have negative 1 over infinity, and then so that becomes 0. And then after that, we have minus minus, which is plus, and then 1 over 2. So this is our final answer. We can rewrite it if you like in the form of 1 over 2, 1 plus ln 2. I hope that this is helpful. Thank you.